Going back though to our polynomial regression, we had simple models and we had complicated models. Simple models were things like straight lines. There was only one or two or three features, and when we fitted those models, the coefficients were very low. Complicated models fitted stupid models, at least when you only did it once and you didn't have loads of repeated samplings of the data. There were many features and there were very high coefficients. We should now be able to say with a certain degree of confidence that we understand it when somebody says that this particular model over here is going to suffer from low bias, because on average, if we could repeat this modeling process again and again and again on different samples, the model would be perfect, but it has very high variance because the individual models are completely overfitted to the data, whereas the simple models have exceedingly high bias and a low variance. It seems, therefore, that there is a trade-off between bias and variance. Simple models have high bias and low variance, complex models have low bias and high variance, and if we could find the perfect mix in the middle, we would find the best model that we could fit, given the amount of data that we have and the number of features. How do we do that? Well, under traditional linear regression, there were things such as stepwise regression, where we started off, for example, with one feature and we somehow measured how good that model was, and then we tried adding another feature, maybe x1 squared, maybe x2 squared, and we saw if there was an improvement, and if there was, we kept whichever variable or feature gave the best improvement, and we tried adding more and more features until we found the best model, after which there was no improvement. Or we started from an exceedingly complicated model, and we saw which variable we could remove or which feature we could remove without reducing the statistical effectiveness of the model. That's how it used to be done. How have things changed now? Well, the main change is that both simple and complex models are going to have access to all of the features. Now that's strange. If we give simple models access to all of the features, what's going to stop them totally overfitting? They're just going to be like complicated models. Well, if you remember, complex models with all of the features had very high magnitude coefficients. If we can somehow force the coefficients to get lower in some sensible way, we will be able to generate simple models using all of the features. And if there was some control we could use on whether to have high coefficients or low coefficients, maybe we'll call that control lambda, then just by varying lambda we can have simple models or complex models, and the idea about getting the optimal bias variance trade-off turns into how can we get the optimal lambda.